Okay, section 7.2. Now we are going to be working with the x-bar distribution that we just talked about, okay, in 7.1. Now, first of all, these first examples, we're starting with the normal distribution. So immediately we know we can change x-bar into z using this formula, okay? So the diameters of oranges from a Florida orchard are normally distributed, okay? With a mean mu equals 3.2 inches and standard deviation sigma equals 1.1 inches. A packing supplier is designing special occasion presentation boxes of oranges and needs to know the average diameter for a random sample of 8 oranges. What is the probability that the mean diameter x bar for these oranges is smaller than 3 inches? Okay, so we want the probability that x bar is less than 3. Okay, if you put an equal to in there, that a less than or equal to, that's fine. It's not going to matter. Now we need to change x bar into z. We don't have a table to find the probability for every x bar distribution, but we do have a table for our standard normal distribution. So we're going to change this into a z. So this equals the probability that z is less than, and now we're going to use this formula, x bar minus mu. So 3 minus 3.2 over, and then I have the sigma divided by the square root of n. So sigma is 1.1 divided by the square root of our 8 oranges. So this is the probability that z is less than. Now when I work this out, let's see if we can see this. I do parentheses, 3 minus 3.2, close my parentheses, okay, divided by, and then parentheses, 1.1 divided by the square root of 8, close the parentheses for the square root, close for my denominator, equals, z always goes 2 decimal places. So I get negative 0.51. This is an area to the left. Our z table gives us area to the left. So I'm going to go to negative 0.51, and I get 0.3050. So 0.3050. Okay? Let's look at the next one. We want to know the probability that the mean diameter for x bar for these oranges is longer than 4.5 inches. Okay, so the probability that x bar is greater than 4.5. Again, if you put greater than or equal to, that's fine. So this is the probability that z is greater than x bar, so 4.5, minus mu, which is 3.2, over sigma 1.1 divided by the square root of n. So 1.1 divided by the square root of 8. Again, this is the probability that z is greater than, okay? Parentheses, 4.5 minus 3.2, close parentheses, divided by, parentheses, 1.1 divided by the square root of 8, close, close. I get 3.34. This is an area to the right. When I look up 3.34, I'm going to get area to the left. So I have to do 1 minus whatever that is to get area to the right. So 3.34 is 0.9996. So 1 minus 0.9996 is 0.0004, or 0.0004. All right. Good. All right, between. We want the probability that the mean diameter x bar for these oranges is between 2.5 and 4 inches. So the probability 2.5 is less than, if you put an equal to, that's fine, doesn't really matter, x bar less than or equal to 4. All right, got to change them into z's. So the probability 2.5 minus 3.2 over 1.1 divided by the square root of 8 is less than or equal to z is less than or equal to And then 4 minus 3.2 over 1.1 divided by the square root of 8. Okay, so this is the probability that, let's see, 2.5. We get negative 1.7999, so this is negative 1.80 is less than or equal to z is less than or equal to 2.06. Okay, so on the betweens, we looked them both up. Larger area minus the smaller area. So I'm going to look up 2.06 because that'll have the larger area to the left. So 2.06.9803. So 0.9803 minus, and then the area to the left of the negative 1.80. So go to negative 1.80, and we are at 0.0359. 0.0359. So 0.9803 minus 0.0359, and we get 0.9444. Okay. And I'm going to stop right there. And so there will be a part 2. Anyway, let me know if you have any questions.